Next we will see the unit symbol, letter symbol for electrical quantities. So in this we have to see the unit symbol and letter symbol for different electrical quantities. So first we will write here the electrical quantity. Next we will write here symbol. Then we will write here a letter symbol, and after that we will write here unit. So first electrical quantity that we will take here, that is voltage. So there are two types of voltage. First is AC voltage and next is DC voltage. Now the symbol for AC voltage is this. This is this symbol for the AC voltage, and the symbol for DC voltage is this. This is the symbol for DC voltage. Next, the letter symbol for AC voltage, it is denoted as small e or small v, and the letter symbol for DC voltage is, it is denoted as capital E or a capital V. So the DC voltage having letter symbol of capital E or capital V. The unit for AC voltage as well as DC voltage, both are measured in volts, and this volt is denoted by capital V. So the unit for AC voltage as well as DC voltage is volt, and it is denoted by capital V. Next electrical quantity we will take, that is current. So there are two types of current, AC current as well as DC current. The symbol for current is this. This is the symbol. This arrow indicates the direction of current. So this is the symbol for current. This is the symbol for AC current as well as DC current. The letter symbol for AC current is small I, and the letter symbol for a DC current is capital I. So AC current is denoted by small I and the DC current is denoted by capital I. The unit for AC current as well as DC current is, both are measured in ampere, and this ampere is denoted by capital A. So the unit for AC current as well as DC current is ampere, and it is denoted by capital A. The next electrical quantity we will take here, that is resistance, and the symbol for a resistance is this. This is the symbol for a resistance. Resistance, it can also be drawn like this. This is also the symbol for a resistance. The letter symbol for resistance is capital R. Letter symbol for resistance is capital R, and the unit for a resistance, the resistance is measured in ohms, and this ohm is denoted by this. So this is ohm, the unit of resistance. The next electrical quantity that we will take here, that is inductance, and the symbol for inductance is this. This is the symbol for an inductance, and the letter symbol for inductance is capital L. Inductance is always denoted as capital L, and the unit for inductance is Henry. Inductance is always measured in Henry, and this Henry is denoted by capital H. So Henry is what? It is the unit of inductance. The next electrical quantity that we will take here, that is capacitance. And the capacitance is having this symbol. So this is the symbol of capacitance. The capacitance having this symbol also. This is also the symbol for a capacitance. This is polar capacitor and this is a non-polar capacitor. See here, positive and negative, these are the polarities shown here. So this is the symbol for a polar capacitor and this is the symbol for non-polar capacitor. The capacitance having a letter symbol of capital C. The capacitance having a letter symbol of capital C, and the unit of capacitance is farad. Capacitance always measured in farad and it is denoted by small f. Capacitance is always denoted, the unit of capacitance is always denoted as small f. Next electrical quantity that we will take here, that is reactance. And this is the symbol for reactance here. The reactance is denoted as, or letter symbol of reactance is capital X, and reactance is always measured in ohms, and this is the symbol for unit ohm or unit of reactance, that is ohm. Next electrical quantity that we will take, that is impedance. So the impedance having this symbol, this is the symbol for impedance. The impedance having a letter symbol of capital Z. Impedance is denoted as capital Z and impedance is also measured in ohms, and this is the symbol for the unit of impedance, that is ohms. So these are the units, symbols, letter symbols for different electrical quantities. Next we will see the conversion of higher units and the fractional units, higher units and the fractional units into the required unit, Next we will see the conversion of higher unit and fractional unit, conversion of higher unit and fractional unit into the required unit, Now first we will take here some of higher units. So here we will take some of higher units are kilo, then mega, then giga. These are the sum of higher units we are considered here. The letter symbols for higher units, they are always denoted with capital letters, such as kilo is denoted as capital K, mega will be denoted by capital M, and giga will be denoted as capital G. Now if we have to convert these higher units, then it must be, the unit must be multiplied by 10 to the power. That means if we have to convert this giga, then we have to multiply the required unit by 10 raised to 9. Then if we have to convert this mega, Then we have to multiply the required unit by 10 raised to 6. And if we have to convert this kilo, then we have to multiply the required unit by 10 raised to 3. So this is the technique to convert higher units into required units. Next we will see the conversion of sum of fractional units. Sum of fractional units into a required unit. Now see here, we will consider sum of fractional units such as milli, then micro, then nano, then pico. Now the letter symbol for these fractional units, they are always denoted with small letters such as milli. It is denoted by small m. This micro, it is denoted by this mu here. Then nano, it will be denoted by small n, and pico, it will be denoted by small p. Now if we have to convert this fractional unit into the required unit, then we have to multiply the required unit by 10 to the minus of power. So if we have to convert this milli, then it will be 10 raised to minus 3. Then if we have to convert micro, then it will be 10 raised to minus 6. It is nano, then it will be 10 raised to minus 9. And if it is pico, then it will be 10 raised to minus 12. So when higher units are converted, then the power will be plus. And if fractional units, if they are converted into a required unit, then the power will be in minus. Now we will see some examples here. So first example that we will see here, that is, we have to convert this 1.5 kilovolt into volts. Now see here, 1.5 kilovolt, we have to convert this 1.5 kilovolt into volt here. So if we have to convert this 1.5 kilovolt into volts, then we have to multiply this 1.5 by 10 to the power 3. See here, the conversion for kilo is 10 raised to 3 here. So 1.5 into 10 raised to 3 volts. Now see here, 1.5 into 10 raised to 3 means 1.5 into, it will be 1000 here. 10 raised to 3 means 1000. So 1.5 into 1000 volts. So 1.5 into 1000. It will be 1500 volts. So this is the conversion for 1.5 kilovolt into volts, and the symbol for a unit volts, that will be capital V. So 1.5 kilovolt is always equal to 1500 volts. Next example we will take here, that is, we have to convert 0.006 megahertz, 0.006 megahertz into kilohertz. So hertz is what? It is the unit of frequency, and we have to convert here 0.006 megahertz into kilohertz. Now see here, 0.006 megahertz, that should be equal to, what is conversion of mega? 10 raised to 6 here. So it will be 0.006 into 10 raised to 6 hertz. So this is the conversion of megahertz into hertz, that is 10 raised to 6 hertz. Now what we have to convert? We have to convert this megahertz into kilohertz. So we can write this as 0.006 into 10 raised to 3 into 10 raised to 3. We can split this 10 raised to 6 into 10 raised to 3 into 10 raised to 3 here. So 10 raised to 3 into 10 raised to 3, it will be 10 raised to 6. Then we will write here hertz. Now 0.006 into 10 raised to 3, it will be equal to 6 here. 0.006 into 10 raised to 3, it will be equal to 6. So 6 into 10 raised to 3 hertz. So this will be the conversion of megahertz into hertz, but we have to convert this megahertz into kilohertz. Now see here, this 10 raised to 3 hertz, this 10 raised to 3 hertz, that will be equal to 1 kilohertz, because 10 raised to 3 is equal to kilo. So we can write here, it will be 6, 10 raised to 3 means kilo, and then we will write hertz as it is. So 0.006 megahertz is equal to 6 kilohertz. The next example that we will take here, that is, we have to convert this 2800 milliampere into ampere. Now see here, we will write first 2800 milliampere as it is. Now we have to convert this 2800 milliampere into ampere. Then 2800, that is 2800 into what is conversion of milli, that will be 10 raised to minus 3. So it will be 10 raised to minus 3 ampere. Now we can write this as 2800 into 1 divided by 10 raised to 3 ampere. Then we can write here 2800 divided by 10 raised to 3 means 1000. So 2800 divided by 1000 ampere. Now we can write this as 2.8 ampere, because this 0, this 0, this 0, this 0 will get cancelled here. So 28 divided by 10 will be equal to 2.8. So 2800 milliampere is always equal to 2.8 ampere. Next example that we will take here, we have to convert this 0.01 picofarad into farad. Now see here, 0.01 picofarad. Farad is what? It is the unit of capacitance. So 0.01 picofarad into farad. So 0.01 picofarad is equal to 0.01. What is conversion of pico? It is 10 raised to minus 12. So 0.01 into 10 raised to minus 12 farad. It is a conversion of 0.01 picofarad into farad. Next example that we will take here, we have to convert the 1200 hertz into kilohertz. 1200 hertz into kilohertz. Now see here, to convert this 1200 hertz into kilohertz, so 1200 hertz, we can write this as 12 into 100, 12 into 100 hertz. Then we can write this as 1.2 into 10 into 100 hertz. See here, the decimal point is shifted on left side of this rightmost digit. Then it will be 1.2 into 10, and we will write 100 as it is here. Now we can write here 1.2 into 10 into 100, it will be 1000 hertz. Now we can write this as 1.2 into 10 raised to 3 hertz. 1.2 into 10 raised to 3 hertz. So we are writing here 1.2 into 1000 hertz is equal to 1.2 into 10 raised to 3 hertz, because 1000 is equal to 10 raised to 3. Now next we will write here 1.2 into 10 raised to 3 hertz. 10 raised to 3 means kilo. See here, 10 raised to 3 means kilo, so it will be 10 raised to 3 hertz will be equal to kilohertz. So 1200 hertz is always equal to 1.2 kilohertz. So these are the examples. These are the examples how to convert the higher unit or fractional unit into the required unit.